Hello, in question 4 we have a ready-made histogram for us with unequal bar widths, clearly so. It wants us to complete the table for distribution, in other words work out the number, in other words work out the frequency. Start the clock. Alright, so what have we got here? We've got from 0 to 10, bar width of 10, so 10 multiplied by 0.4, that's what we got there, 4 from there. Now what have we got again? We've got 0.7 times the bar width of 10, so 0.7 times 10, let's do it down the bottom here, 0.7 times 10 will give us 7, so that accounts for 7 hotel guests. Very good. Next one we got 0. Oh, it's very hard to see that, so 0.76 times 20, just about see that, so it's 0.76 times 20, that gives us 15.2 guests. Well, we're going to call that 15, aren't we? It's 15 people there, you can't have 0.2 of a guest, that would be terrible. Just check that right. Yeah, I'm happy with that, 0.76 for sure. Next one, bar width of 20 again, so 20 times 0.54, so 0.54 multiplied by 20, 10.8 guests, that's 11, so it's 0.54. Oh dear, 0.54 multiplied by 20 is roughly 11. And next one's got a spread of class width of 30. 30 times 0.1 is 3, I believe. Is that bang on that? I think so. That's 3. So we've got 0.1 multiplied by 30, and that's the distribution of people in the hotel according to their ages. How many people we got? So 11, 21, 26, 36, 37. We have 40 guests there. Did it say there's 40? It does not, but it could have asked us that, and that was really easy. Okay, so that's how you extract data from the ready-made histogram to work out numbers in each class width. Each class rather. Now, turning over. Now, the grid is ready to go. Right, a restaurant group advertised that they sell particular drinks in 500 ml servings over a period of time. Trading standards officers sample these drinks like they would. Draw a carefully labelled histogram for this data. Well, I've got time, let's just do it, shall we? Again, frequency of 8 divided by 5, so that's going to be 8 divided by 5. Let's do it down here. So 8 divided by 5, that's going to be 1.6. 1.6 right up here. FD is going to be 1.6. Next one, I've got 18, divide that by the width of 3. I can see that's going to be roughly 6, not exactly 6. Next one, I've got 21, divided by a width of 3 again, and that's going to be 7. Next one, I've got 44, bar width of 3, I believe. Yes, it is. No, it's not. 44 bar width of 4. Going too quickly. That's going to be 11. And I've got 15 over a bar width of 5, and that's going to be 3. And I think I've done my scale way too big according to the need. And yes, I have. Never you mind. Anyway, let's just do the maths and see what happens. So let's learn from this. It's a poor choice of scale, just a mistake. Anyway, so 90 to 95, FD 1.6. 90 to 95 is in that facility there, in red, I hope, is going to be 90 to 95, 1.6, 1.246. Yep, that's good enough. Next one, we've got 95 to 98, 495 to 498, FD of 6. So that's there. Frequency density is 6. It joins it just there. Next one we've got 98 to 01, 498 to 501, so that's a width of 3 and a height or FD of 7. 501, height 7. There, so 6, 7. I'm quite disappointed with this scale, really. Don't do the same, that's naughty. Next one, 11 up to 505. 505, 11. Should be twice as big, shouldn't it? It's just so bad. There we go. It's looking good. Ish. And the last one is going to be heights of 3 and go up to 510. So 510's there, height of 3, 2, 4, 3's bang on there, isn't it? That's it. And that's the histogram with unequal bar widths for these cans of drink. And that's quite easy, really, except this should all have been twice as big. And please forgive me. Now, next bit. Estimate the proportion of drinks which are under the advertised volume. Right, well, here we go. To be under the advertised volume, you've got to be 500 or below. So let's just take a look at this histogram. And what have we got? We've got 8 and 18. So I know for a start that represents 8 in the area, that represents 18 in the area, and somewhere here, let's just chop it down there, somewhere down here we have an area which represents a certain amount, and these ones plus these 18 plus this 8 represents the actual number of tins sampled which are below 500. Therefore I can see from 498 to 500 I have a bar width of 2. I know my frequency density is 8, so we just label it as such. So my frequency density is actually 7, and then I need to go 7 times 2, do it up there, may as well. 7 times 2 makes 14. So this area here is 14. Altogether I have 14 plus 18 plus those 8. What does that come to? 20, 32. That is 40, isn't it? That's quite a lot. So I've got 40 of these tins that are potentially below the advertised amount. Let me just check that again. There we go. Yes. Terrible. Right. What proportion do we have? Well, it's 40 out of how many? It does say the word proportion, doesn't it? So that it would imply just do a fraction or a percentage. What have we got so far? Doesn't tell us. Let's get the total. We've got 8 plus 18 plus 21 plus 44 plus 15. Okay, we have a sample of 106. Let me just check that. It's a horrible number. 8 plus 18. Who'd sample 106, honestly? Plus 21 plus 44 plus 15. Okay, that's what the math says. So I've got 106 in total being sampled. Crazy number. So anyway, so I've got 40 cans out of the 106 which are below the advertised volume. Let's do that as a percentage, shall we? So 40 divided by 106 is 37.7. Approximately 38% of the cans are below the advertised volumes. Therefore, the public in those cases are being conned out of the advertised volume. They're paying more than what they're actually getting. And if Trading Standards samples that more closely, fines will be due for that company, plus court appearances and all the rest of it. Comment on your answer to part B in the context of the question. Well, a very high proportion, 38%, have servings that are below the advertised amount. This could lead to legal proceedings against the company. Well, not that this is a law issue in the mathematical context, but it's a very, very high proportion, and Trading Standards could take the company to court over that. Alright, let's look back at the final amount. There it is, 38%, based upon the data given. That's really high.